And we have gone live. I am
I
going.
can't hear you. If others can hear, I'm not sure.
Yeah, hold on. Just let me send a message to Raghavendra.
Guys, can you all hear me?
Can you hear Raghavendra?
Yeah, I'm not sure. Like, let me introduce myself and let's get started.
Okay,
You
hold on
got
a
your
second.
all of you can see me and also can hear me, right? If you can, please can anyone of you confirm me in the chat window? Cool. So thank you so
Hold
much
on
for the confirmation.
Raghavendra, one moment.
Okay.
One moment.
Yeah, sure.
Okay. All right, I need to start our live stream for our LinkedIn audience. It will take me just a few seconds and then we'll get going. Apologize for this. We have audio problems on Raghavendra's side, where we can hear him, but he can't hear us. Get that sorted, but in the meantime, oops.
what is system design, why it is important, and then in the next 45 minutes, I'll be spending the time for designing the Instagram. Okay, that's the topic. Yeah, it is definitely very difficult for me to talk everything about it, but I'll try to keep it minimalistic and I'll try to keep as much as possible brief. Okay, I want to cover most of the things, but I'll see how much we can cover, and I'll try to keep it again, try to cover end to end as much as possible. Cool. So about
What is
myself,
system design?
why it is
Raghavendra, I
important,
am
and then
staff
in the next
software
45
engineer in
minutes,
one of
I'll be
the
spending
software
the
and
time for
companies,
designing the
and
Instagram.
I have
Okay,
close to
that's
nine
the
years
topic.
of experience, and I have
Yeah,
conducted multiple
it is
webinars
definitely
and
very
masterclasses across platforms. And I also conduct trainings and regarding DSA, algo, system design, and then full stack, mean, all those topics. I'll be conducting sessions across multiple clients, including Simplilearn. That's about me. And today's agenda mainly is we'll understand what is system design, and it's very important for us to understand how an application work. And we'll also see if we want to design any website or anything, what concepts and components we need to keep in mind. And in the time we will be designing a design problem called Instagram. Okay. So this is what the today's agenda will be. Okay, now what is system design? Okay, people get confused in this. It's a process of defining components, APIs, database tables, etc. for the system to satisfy specified functional and non-functional requirements. People who are in the college grads time, for you guys, it might sort of very Greek word for you. What is this requirements and all? Maybe you guys might have learned in your college days to build an application or a software. A requirement phase is very important, right? This is what actual application system design, functional and non-functional requirements, what has been practiced in real time in the industries. So now let's break it down to make it easier for all of you to understand what is the system design. Let me make it full screen. Okay, system design means it's a combination of the system design. Okay, again, I'm just trying to make it simpler. So in the system, what we do, we assemble multiple components. Okay, uh, I'll just stop sharing my the webcam because I'm facing some bandwidth issues. Sorry about that. Okay, so the system actually, when we speak about that, it is an assembly of different components for a specified requirements. And when we say design, we speak mainly about how efficiently this different components, whatever we have as assembled. Okay, so that's the main thing we need to understand. Like for example, if you see here, we have Instagram, Facebook, Uber, WhatsApp, YouTube. All these things starts from the slate or the black whiteboard. From there, things starts, right? So now, how do we approach this if it is coming in an interview? Okay, because this is how it may be in an interview or may it be in your work practices. If this question is given to you, how do you approach that? Okay, the answer is simple. You need to first sit down and understand what and all the requirements you want to get first. There are two different categories. Okay, one is functional, other one is non-functional. Yes, we see them. What are those two different things are we considering here? Okay, I'll talk about that in a while. For an example, when we take an Instagram again, but before then, let's go through those steps. What and all we need to consider. Okay, and we'll be talking about the estimations. When we say estimations, it's very simple saying that what capacity we'll have. For example, let's say a crucial point to keep in mind in this kind of a situation is the number of reading requests will be 100 times higher than the number of uploads. Okay, or the writing request. Okay, I'll come to that again. This is mainly about the capacity for one day. I will show you literally in a way where you can understand in a piece of paper, and then we'll understand high level design. There we'll talk about architecture, then user on how do we onboard the user, that means signing up. How do we store the users, what cluster we'll be using, what cache mechanism we'll be using, and how do we store all those things, where Kafka comes into the picture, and all those things. What is Kafka? So again, those pointers. And then we'll talk about data model. In this one, we'll be talking about what components are there and what all the data models we'll be having.
It can be a database or it can be anything. Okay, it can be, if it is database, let's say a photo is a table, user is a table, user flow is a table. There are multiple components again in here. We'll see that. Okay, and high level design, here I'll be talking about again detailed architecture of what is load balancer comes in, where my cache comes in, where my Kafka comes in, all these things. Okay, that's what we talk about in this particular high level design. In detailed design, whatever I told in the high level, I have to elaboratively explain to make sure the interviewer or in your application, uh, this all these components whatever we have will be need to explain for and justify why I am using this. If you are having a work, if it is question is, if a requirement is given to you, may it be designing a complex system like Instagram, or may it be a simple functionality, you need to start in a specific manner, and this is what the manner I'm giving you. So this is the kind of a handbook for you guys to, whenever a task is given to develop, you need to follow these specific steps. Okay, after that, then let's understand how does an application work for a newbies. This would be a very useful like diagram, because in this diagram it says end to end what exactly happens in a brief. Okay, first of all, what do we do? As a user, I collect data from the user. What collect data? Again, it can be username, password. If they are signing up, then I can capture the data for username, password, and their first name, last name, address, phone number, etc., etc., etc. Okay, and again, how this is been done. Okay, whenever you say google.com, okay, and sign up, it goes to the backend, get some HTML, CSS, JavaScript contents, and display it to you. You will enter some information and goes to the backend and does the next further processing. Okay, when I say that, how that happens, it will go talk to the backend server, whatever we have. We will make sure that it communicates to database, also it communicates to the file system, whatever it needs to display in the UI, and finally we get the response. This is how this all communication works, right? So that's about this entire end-to-end application working looks like, right? Now, what all things one has to consider when we actually have a given a system design question to you guys. Now, what are the different architectural pieces that can be used to solve given a question? That is very important. And now, how do we, what are the different pieces we have at this point, and how do I integrate them? That becomes a very crucial part in it. Okay, and also we need to make sure that how can we best utilize those pieces with trade-off. When you say trade-off, are we leaving time complexity for space complexity, or are we compromising with one another? Or we have to think, whenever a question is given to you, you always need to choose one over the other. That is what CAP's theorem is all about. I'll talk about that in a while. What is CAP theorem and how useful it is for us, right? So that is one thing. And then system design and components. What all the components when we are actually going to build a system, we need to consider. These are the components. We have load balancing, or we have caching, we have SQL, NoSQL, we have gateways, we have CAP theorem, and many more. This is a very big list of things which we'll be considering. Okay, if I have to mention, in apart from this, we have data partitioning, we have indexes, we have proxies, redundancy, replication, long polling, WebSocket, server sent events, what else and what not. That the list keeps growing bigger, because those many things one has to know to actually build a system. If you are feeling overwhelming, don't bother about that. That's why I've given you the concepts which are catchy enough and needed for you guys to at this point to get started with you guys. Folks who are seeing for the first time, these are your starting points for you guys to start your journey towards a system design. Okay, out of which I want to speak about first topic in this entire many more and the big concept, that is what is load balancing. Okay, load balancing or a load balancer is one of the critical component of any distributed systems. Okay, what does it do? It helps to spread the traffic across the cluster of servers. Okay,
If you guys know server well and good, server means the kind of place where you get the request. Okay, and from there we decide what response I need to send. Now, this server, let's take an example of Instagram because we're talking about that. Now, at every given point of time, I get thousands of requests to make sure to see. Generally, in the Instagram, the requests are mainly for news feeds. When I say news feeds, you open Instagram just to scroll up and just check what and all the information we have made, to check reels, to check your friends post, or a general news feed, whatever you guys have followed. Okay, those information are the ones you guys are looking here to balance out. Like for example, if I get 10 requests, I'm fine with one server. Let's suppose my system is not able to handle beyond 10 requests. Then what I'm supposed to do is I need to add multiple servers, and I need to keep one middle guy called as load balancer. What is the responsibility of load balancer? A balancer, what you need to do, if you get a request till 100, you send it to me, the first server. If you get request beyond 100, you route it to second one. If you get beyond 100 or 200, you send it to third one. Again, like that, if I have 10 servers, those requests are properly segregated, right? How? There is a strategy for that, to do that. And what is that? This is the one I'm showing you. There are round robin fashion of allocating servers in the system dynamically. Okay, guys, is my voice not clear to everyone, or is my voice not audible to any, like, is it low?
And I'm hearing it fine.
Yeah, but there are some folks who are complaining about the voice. Cool. Thank you, folks. I'll carry on. So in this one, there are three to many actually strategies we have. We have round robin, we have IP hash. Don't bother about these techniques. Understand that these techniques are used to make sure, if you get hundreds of requests, how do I make sure my request is, let's say this IP is user 1, this IP is user 2, this IP is user 3, or this IP is user 1, this IP is 201, this IP is 301. Okay, I keep on routing such IPs in different places. Why? Because I need to make sure that those requests are not bumped upon in one single server and make it heavy, and that what happens, latency increases. So by balancing those information, my system will not break because of huge requests coming in. It's always distributed across multiple servers. Okay, that is why load balancing is a very crucial topic. If I want to give you the best example for this is your Hotstar. Okay, how Hotstar, the day India Pakistan match is there, for example, coming Sunday, you go and check the previous day, you will have maybe 10 lakhs people are watching a match. The next day, you will automatically see 1 crore people are watching the match. How do they scale up that much? You need to think. Okay, whenever you see such problems, first of all, you guys need to think what is the purpose, how people are handling such a request from 10 lakhs to 1 crore. That's where this load balancer plays a very vital role on handling all the requests coming in, smoothly sending them back. This ensures no single server bears not too much demand, rather than splitting it across or spreading it across evenly across all the servers. That's why load balancing improves application responsiveness. Okay, it also increases availability of the application and websites for users. Why I say this point? Because when I say availability, the system, whenever I open Hotstar, it is available for me to watch cricket match. Okay, or if I open Instagram, it is available for me to browse my photos or have my news feeds. That's what I mean by availability over here. Okay, this whatever I'm telling about this load balancing, right? This can not just only happen in the front end to other web servers. This can happen at every stage. Okay, may it be application server, may it be database server, may it be whatever other components we have. Okay, load balancer is also one of the server. Yes, it is responsibilities to redirect the request to specific servers. That's it, to the backend, if you want to say. Okay, it's like a traffic signal. It redirects whichever guys you come, you go. Okay, like that it is. And maybe if you go to a toll, okay, if you toll booth, if you guys all remember, or not all of us will go to single tolls, right? There are multiple toll booths for us, and we ourselves redirected to separate tolls. We are actually load balancing ourselves. For us, in software, someone does that responsibility. Now the road suddenly widens up the moment we go to toll booth, right? Out because there are already predefined booths to cross across. That is what you call it as servers. Server 1, server 2, server 3, server 4, etc. In our case, that split will not automatically happen, and that's the reason load balancer will play that role to split those requests to multiple people. Okay, that is what the main use of load balancer, and this is exactly is used in Instagram, designing also. Okay, my point here is to talk about all these basics. It is very important when I speak about load balancing in Instagram design. Okay, so these are some techniques. Now that is done with the load balancing. Now the next topic is caching. Okay, what is caching? Okay, caching means, now if you see this example, this is a wonderful example now to make you all understand what actually happens if the caching is not in place. Let's understand that. Okay, for the first time, even though caching is there, visitor one comes here. I am a visitor. Okay, I just say, hey, I need the page, and the page name is www.instagram.com. Okay, and now system what it will take is, it will now so, okay, go and check a cache. Do you have instagram.com in your page or in your cache? Do you cache it? No, I will. As of now, I don't have. I'll build it. So what happens? There is some backend processing happens, and finally it reaches database. In database, we have those information about the Instagram or whatever information I'm looking at. It takes it back and passes it back through the cache, saving the data. Not everything is saved in the cache, only necessary information is saved in the cache, and this request is sent back. Now, next time, sorry, this is with cache. Okay. This is what happens. Second user comes in now, right? What he does is, hey, I need the page, and the page is www.instagram.com. And now it goes to the backend. And now, instead of me going through all the layers and reaching database, I have already cached this page in my system, just like your RAM, whatever we have. Okay, this information is stored in the cache, and now that has been returned back to the user. So this is the main purpose of cache. Okay, so this, without this and with this, there's a lot of difference. The main problem is this increases latency. Latency means the fetch time will automatically grow high, and that is being avoided for us with the help of cache. Okay, that's why cache plays a very important role in the system design world. Okay, so now if you see, where and all we can have cache is one of the very crucial things people generally miss out. Okay, the cache can be present in browser for a browser cache, or it also can be part of page cache. We can also keep a CDN cache. We can have a database cache, and we can have all possible layers, each and every component places. We can have our cache in place. Okay, that is the main reason cache is used. So these are some of the places. So if you see, this is the one cache, this is second, this is third, this is fourth, this is fifth. Totally there are 5 different places where we can have cache. Okay, let me move on. Okay, so there are eviction policies. Okay, what is eviction policies? Eviction means, now let's say my cache size is, I'll just about one eviction policy here. I'll give you an example for you guys how this eviction policy works.
These are some of the eviction policies. I'll give you one example in detail. Okay, and that is, let's say I have first in, first out. I have, these are the some of the strategies. Okay, I have first in, first out, last in, first out, least recently used, most recently used, last frequently used, or randomly replacement. These are some of the strategies. Okay, in each and everything, we will have one different strategy. Now, I want to pick one of these and I'll explain you in detail about that particular cache. Okay, in that, which I'm going to pick here is, I'm going to pick LRU so that you all will understand how do we use it, right? I'll just show you. Okay, now for LRU cache, there are two things which are used for us. And what is that? One first component is linked list, and the second component is hash map. I'll just show you. That's the reason I made it as an empty page to write and show you guys. Okay, now let's say the request comes in. Let me open a notepad plus plus. Sorry, 1 year. Yeah, exciting. Now let's say the request comes in. Whenever a request comes in, let's say I have request one. Okay, and then it passes information as A. Now I am looking for A as a page. What happens? Let's suppose I have this information in my cache and I have doubly linked list and I have a hash map. This is my hash map. This is also a kind of an algorithm which is used for a LRU, and this is linked list. I am telling you again, this is a doubly linked list. Now A comes in. What happens? It moves A to the cache. Okay, and also it adds this information in the hash map. Now second comes in is B. Let's suppose my cache size is 4 only. Now I'll add this to the B. Sorry, this will be reversed. So you will have B here. Whenever the whatever the recently used, that means LRU, that comes in the first. Whenever B comes in, A will be pushed back to the second place and B will be added over here. Okay, because whatever least recently used will be considered first. Okay, so this is the one. Now this came at last, and this was considered. Now A. Now next time, let's say I get A only, then these get swapped like this. A will be become first, B will be afterwards. After this, let's say I get C, and may in the hash map, let's say the size also 4, and this also size is 4. Okay, next I get C, then C will be added. Next I get C will be added, not here but in the beginning. Okay, next I get D, and D will be added in the beginning. This is how your cache will look like. In the hash map, it doesn't matter, it will add all the values. Now cache is full. Now in future, let's say I get D and also I get E, or if I get E, because size is already filled, right? Now what happens in this big list? What is least recently used? How do we decide that? We decide that only by the element present in the last location. In this case, B is the element which is present in the last location. So I discard this. Now my new cache will have E at the beginning because
B was at the last location. My cache is currently filled with data. I'll move this data outside of the cache, and this is called as eviction policy. Remember, very important word, eviction policy. This is whatever we are discussing. Okay. And now let's say I get A again. If I get A, no, here also it will remove B and adds E over here in the hash map. In both of them, we will actually maintain this items here. Linked list, this is to maintain the sequence of least recently used, and this is mainly for number of elements. Okay, not to maintain the duplicacy. Okay, and now next let's say now I get again one more time A. Then what happens? This sequence will automatically get modified to A, E, D, and C. This goes on. This particular idea goes on. This is how least recently used element cache works, or sorry, strategy works. Least recently used cache. This is okay. Why I'm explaining this? Because one has to know a strategy, how cache works. In that context, this becomes extremely important for us to understand how is scenario cache or any cache. I don't mind explaining about any one of this. The same way discarding happens based on the strategy here. First in, first out, you all know whatever comes first in, it goes out first in, or removes again last in, first out we have. I showed you just now about LRU. Next, most recently used will be removed first. The different caching strategies or eviction policies they have. Okay, that's how these things works. Now again, we have different kinds of SQL and NoSQL. Okay, why this is I'm talking about here? For us, it is extremely important to understand which database we are using. For let's say we have data that is manageable up to thousands or maybe lakhs. It's okay for us to use in normal table based databases. But the moment if the data increases, right? The moment data increases, it's always recommended for us to always go for NoSQL databases. Nowadays, this is very much popular than this because this is old school. Why I'm saying that? Because this follows table based. Okay, table based approach it follows. So whereas this is having different strategies, and in this also everything caters a different use cases. Now if I see graph databases, this caters maybe mainly for now if I discussing about maybe AI and ML, this is used a lot. Again, if you want to do a lot of data manipulation, maybe if you're using data grid tool to show all those data, okay, all data analytics tool, then graph database is very commonly used when we have huge data. And then if you want to access the data and if there you don't want to have the restriction of how those data is saved, maybe just like your JSON. Okay, I have A, B, and in again in the B further again we have B is split across multiple things, all these things. This is again talking about one example of document. This is also one of the very famous example of document databases again. And which one we have in this very famous is in market currently going on is the MongoDB. Okay, these are the things currently we have and very important for us to understand all these things. Okay, now let's move on to the next thing, and that is Instagram. Now all these basics, why I told you, because it is extremely important for us to understand before I talk about this actual Instagram design. That's the reason before jumping on to the system design of Instagram, I want to make sure to explain the components to at least get with my pace of understanding so that you can get those knowledge in a seamless way. Okay. Now, my question is design Instagram. Okay. It's not that simple. Whenever a question is given to you,
you need to make sure you gather those functional and non-functional requirements. Okay, what is functional requirement? Like I already mentioned, it talks about main functionality of a given system. Okay, in this one, what and all the functional requirements we guys can actually have? Photos should be able to uploaded by and viewed by users. Very primary use case of an Instagram is photos, right? And that is what we are considering here as mainly photos should be uploaded, downloaded, and also viewed by all the users. Users can search for photos based on their videos or based on their titles. Even that's important. Okay, and then we have followers. Okay, you follow XYZ person and you follow and they follow you. Both of you should be able to feed each other's data to one another, so that whatever happens in your system, in your feeds, should be sent to him. Whatever happens to in his system should be fed to you. Vice versa should always happen, and that's why this third requirement is also important. We are gathering the requirements now to make sure that how do I build those things. Okay, this is the first requirement I gathered, and I need to work on this and I think about it. This is second requirement, this is third requirement, and this can be, let's say I have a top celebrity, okay, maybe Virat Kohli, okay, and we should follow this. Is, let's say you guys followed him and you need to get feed from him every single time. Okay, you need to get feed from him every single day, whatever he does. Okay, and how do we build those information? We are mainly going to focus here, right? And then functional requirements is done. Maybe you guys are hearing this for the first time. Now the second and very crucial part, what is that? Non-functional requirements. People get often confused with these things, especially the people who are understanding or getting this topic for the first time, right? What are non-functional requirements? Now you have built the Instagram very good, I'm happy about it. Now is it available to users all the time or not? Or what about the latency? Okay, latency means the moment I open, I should see the system feed automatically running in. So that's what latency, how much this latency we can allow. So, and that's what we are given as 200 milliseconds. That means very less latency I have. And what about consistency? What is consistency? I'll give you an example. Okay, let's say that you upload a photo. Okay, you upload a photo, and you if you upload a photo, it immediately might not come in the others feed. Okay, it might not come in the others feed immediately, because goes to system, loads in somewhere. We'll discuss about that in detail. And finally, it has to identify your all the followers, then go on feed. When they open, it should be visible. Or to view in your profile only, it will take some time. But and that is okay for us. For me, if I open Instagram, what is the bare minimum my expectation is? I need to see news feed seamlessly. That is my minimum expectation. And if I see the uploading of the photo a little late, I don't mind. Okay, and that is what this Instagram's main, I mean, I am considering all these points as a very important thing. And reliability, what is reliability? Now if I open the system, how much reliable I can on this? Okay, it should be highly reliable. Means whenever I open Instagram, however I open Instagram, if it can be mobile, it can be system, it can be tablet, whatever, the moment I open, I should be able to get the data without fail. That is what reliability. We can rely on Instagram for any of our businesses or ads, business ads, things and all. And if I go and say these are the people my post should come, then those things will definitely will be appearing in their users' feeds. And that's what we call it as reliability. And that is a very important consideration for us. Okay, then what else? Let's move on. Now we have actually got all the system non-functional and functional requirements. Okay, now
These are my design considerations. Now I am building the design. Now what and all I need to keep in my mind. Okay. My system is read heavy. Okay. When I say read heavy, how often you tell out, you guys only think about yourself, how often you upload, or how often if you open Instagram, let's say 10 times a day. Okay, in that 10 times, how often you upload a video or you view the news feed? 99% you just go for the feeds. Okay, but other maybe 1% you go for uploading. The rest 99% you go for just checking the news feed, what's happening in some other's life. And that's what called as read heavy operation. We mainly focus on news feed. Okay, that means system can retrieve photo quickly, and that is very, very important. Okay, and when we do that, the latency should be bare minimum. That means while viewing those photo, it should not take a lot of time for loading those photo, and that is one of the major consideration when we are building an application like Instagram. Okay, so and now let's say I upload the user, I upload a photo. I don't mind if the photo comes after a minute, but definitely I mind. Okay. Okay. Definitely I mind if my photo is not at all uploaded or if it is lost. I definitely mind this. This is extremely important. This is what called as reliability. Whatever I do the operation, that has to be present in the system, no matter what. That's what we call it as reliability. Okay. Now, these are some of the design considerations I am making before I start designing my actual Instagram. Now, capacity estimation. The crucial point to keep in mind is that the number of requests will be 1,000 times higher than whatever the number of writing requests. Same thing we discussed here. Read heavy means people always expect to load the data than upload the photo to the system. Okay, let's assume that we have 500 registered users in our platform. Okay, okay, in that we have, let's say, only 1 million active users every day. Okay, if 5 million images are posted every day, the number of photos uploaded in 1 second is the estimation I'm making here. Now let's say this one, I'll make a new estimation. If 5 million images are posted every single day, that means the number of photos uploaded in every second is 1 second is equals to 5 million into 24 hours, 60 minutes, 60 seconds. Okay, if you, sorry, if this is a division, I'm sorry, if you divide by this, what happens? Approximately, this is approximation, you would be getting 57 photos will be uploaded every single second. This is the estimation I am making based on my current assumption. Okay, I repeat, I am making based on my current assumption. Okay, now let's say each and every photo, okay, each and every photo is of size 150 KB. Here I'm telling 200, I can have 150 also. Now I want to show differently than this, so I'm taking these different numbers here for you guys. Now let's say 5 million photo, whatever I have. Now if I multiply this with, let's say, 150 KB I have for every photo, then it will approximately come up to 716 GB. Okay, this is how storage for us. This is 1 day storage for us. You need to do same way in your interviews. Whenever question is given to you, you need to take some approximations and keep on building on top of it to achieve to the end goal. Always make capacity estimations that will also help you in understanding what data I will be needing. Okay, so that's the one more estimation I wanted to make. And now third thing is, now let's say if we assume our service continue for next 10 years just like this, 716 GB, if I talk about 365 days into 10 years, it would approximately come up to 2553 terabyte of data I will be needing. Okay, so totally it is approximately 2.6 petabytes of data I need. Okay, this number is extremely useful for us because one has to understand how much data we need to keep, or my database, what is the capacity you should have in growing ages. This is I'm roughly calculating as of today. Now if tomorrow or in coming days user base increases, this number can grow exponentially. Okay, this number can grow exponentially. Now if I talk about different estimations whatever present in here, let us see how that number looks like. I showed you for 5 million. Now here I have took 2 million photos uploaded every single day. Then it will leave up to 23 new photos every single day. If one photo having 200 KB, it would result in 400 GB of data storage we want for 1 day of photos. Now if I talk about 10 years, it would cost me, I would be wanting 1.4 petabytes of data I would be requiring. Okay, this is how you need to make the capacity estimation. Once you make the capacity estimation, you now have a picture in your mind. Okay, this is how this much data I want. Now I am building the system for this heavy information which comes through my system and passes on. Okay, now the next topic is, how do I talk about high level design? If you notice in the initial slide, I have shown you guys how to go step by step. First step, I told you to do design or capacity estimations. That is exactly the same thing I just now did. Now I am moving on to high level design. Okay, because we have shortage of time, I'll be or a little bit making it faster. Okay, so here we have user onboarding. This can have two different flows. One is login flow, other one is can be sign up flow. Two different flows I'll be having. Onboarding can be of both the things. Okay, it goes to user service. This will be a, again here I have load balancers. I can have 1, 2, 3, 4, etc. I can have multiple servers here. That is why LB comes in. It generally routes like this. Okay, and then it goes, let's say I do all the necessary modification or necessary changes needs to my server, and then I will be saving this data to the my database. Again here also the LB can come in, load balancer can come in. Otherwise again the cluster means that only it is one. Like this I can have multiple. Okay, now this data is put in the backend and it is saved. And here we go. We have the cache. Redis is a cache. Okay, it is generally maintained in the service layer side. Okay, once you save in database, we always will come and write this information in the cache also. Once the data is written in the cache, that will be sent back to the user, user whomsoever is seeing, and that is onboarding. Okay, now let's say I added to the friend. If I add the friend and that is coming to the backend with the load balancer help, look at this graph service I have. Why? Because that add friend can be A is friend of B, B is friend of C, C is friend of D. Again, D can be friend of A can be friend of C. This combination moving across the different friends can easily be achieved with the help of graph databases here. Okay, I'm just showing you MySQL because of the just for the sake of designing the high level. But if you really talk about them, we need to have one information in the backend, and that can be also of graph, which will help us easily navigate across different things. And we have Kafka. Kafka is mainly to redirect. It's just to make things faster and multi-processed. Okay, it will just channelize multiple things in multiple way without having dependencies. Let's not discuss today because we don't have that much of time to discuss all these things. So this is how high level design of a system would look like. Now, moving on, if I have time, I would have explained even more in detail. Let's understand overall components, whatever we have in the system. Okay. Now I can have like this, I can have other components also, but for the sake of short time limit, I'm showing you this information. I have new user feed service, I have follower service. Every service will talk to the backend. Remember that. They will make sure that the data is, if you notice here, Neo4j, this is a graph database. Okay, why I told you graph database? Because friend is a friend is a friend is a friend. Friend of friend of friend of friend can be friend of first friend. That combination can be easily achieved with the help of graph. That is the main reason we have this graph in the backend, and we have user feed service, we have follower service, media hosting service. This is mainly for your photos and videos. Okay, and we have post. Whatever post you make, you make post like this, right? You have a photo and you write something and it will be image you have. Okay, this is what this information will be saved in post service. And we have comments. Whatever comments is made in the use system, and that comes here. We have like service. For every small component, we have its their own services. Okay, and Cassandra is a column based database, and that is used for this student database. Now let's talk about database design. In this, I don't want to complicate, I'm keeping it simple. I have three information. One is your photo table, first one. Second one, user table. Third one, user followers table. Here I gather about user ID, photo path, longitude, latitude, on all this information to locate the user data, okay, or the location where the user currently intend to log in, and creation date. You all tell, right, access by location. Whenever you grant your location, you know what happens in the behind the scenes? These information are passed on to the backend. All of you should understand, whenever you open your mobile phone, when you say share my location, these are the information generally will be saved to the system, and based on that longitude latitude of information, you will be tracked. Okay, so and then we have user ID. Here we have name, email address, birth, date of birth, creation date, last login. These information are specific to the user. And here followers, let's say A follows B, okay, B follows C, and then C follows D. Okay, if I can follow this, this can happen. How all this communication is saved, and these are saved in the user flow or user followers diagram. Okay, so I would like to stop at this particular point. But this was actually, I add this user in newsfeed information where data comes in, and once you upload, it goes to the backend backend database. This photo will be uploaded in the database. Again, we'll be using this S3 bucket for saving those data in the cloud, and this again we will be writing back the photo for a specific database. This is how upload image works. This is how view image works. Both are follow similar pattern. Okay, and if I talk about load balancing in Instagram, every data comes through, goes through application servers, will obviously be cached. Okay, caching is done for every information coming in, because now same user coming in asking me feed data every single time, I can't keep providing them again from database every single time. If it is data is frequently used, let's say Virat Kohli scored century, that image will be accessed by millions of billions of users. I can't go to database every single time and paste out image, right? Now I'll keep this, let's say Virat Kohli's image in the cache.
Every time people ask for this information, I'll send it back. This is how I will do this. There are again different strategies of how to maintain the celebrities information, non-celebrity information. There are multiple strategies, but let's not focus on that. My point is just to talk about all these different LB techniques. Okay, and that's all for today. I have from my side. I think it's 9.
Yeah. Now, Raghavendra, I think you have a hard stop. Is that correct?
Yeah, actually.
Okay. So what I'm going to do is I'll take it from here, and I want to apologize. We have a few questions, but
I can
I'll
answer
pass
those
those on.
questions. Maybe I can take 2-3 minutes more.
Okay. So is load balancing done through a separate server?
Actually, yes, even that's also one place where it is done in a separate server. Yeah, that's correct.
Okay. And Zainab asks how algorithm LRU works with HashMap.
Okay. Basically, how HashMap works is HashMap is mainly used to maintain those information. Let's say I have 5 information A, B, C, D, E. HashMap is used for saving it, or you can use set also to not to have duplicate data. Okay, that is the reason we use HashMap. And for least recently used, we use linked list. The combination of these two is used to achieve the LRU technique.
Mhm. Excellent, thank you. If you will email me afterward when you get a chance, Rick Vendor, if you email me the PowerPoint, I will make a PDF of the slides and share that with the audience.
Sure, I'll send it to you after this session, Stuart.
I appreciate that. And just want to let everybody know I will be sending out a follow-up email with that link and link to the recording so that you'll be able to review what Raghavendra spoke about today. And Raghavendra, thank you. I'm going to let you go and I'll continue on to the rest of the presentation. But
Thank
thank
you
you
so
so
much,
much.
Stuart. Thank you so much, guys. I hope you all understood something useful from today's session. And there will be Stuart will be showing what this mainly we do in this Simplilearn sessions. And I hope you get those points as well from him. And I wish you all the very best. And have a good night, guys, or good morning from wherever you are.
Okay, thank you.
Bye bye.
And what I want to talk about just before we finish is one of the programs that we have. You've seen a lesson. We have different courses available through our Simplilearn.com website, one of which, for people in India specifically, is the full stack Java developer program with a 100% job guarantee. The QR code will take you to that program page, but basically what it is a 6-month program with a comprehensive curriculum where you have live interactive classes similar to one you just were in, but with more tools available so follow along, do the exercises with the instructor, and it allows you to access the other course materials 24/7. So between your weekly classes, you can catch up all the other material for preparation and projects. And this particular program includes a guaranteed job offer on completion, meaning once you finish the 6-month program, we will give you job search support for 6 months. And at the end of that additional 6 months, if you haven't gotten a job with one of our company partners, we will refund your program fees. So the curriculum starts off with object-oriented programming, Java, understanding data structures, algorithms. So then you become a back-end expert with courses on the back-end processes. You look at frameworks and DevOps, and then the front end, and ultimately you finish with a capstone project where you tie all of those skills together into a finished project that you can then use as part of your portfolio and demonstrate your experience to employers. You also have the elective of taking a testing and DevOps course, and Again, what you get out of this is you get your certification, you get 26 or so projects along the way. You can choose your capstone project from 4 different industry domains, and the job guarantee program, which is only available at this point in India. I apologize to anyone in other countries watching today. Based on this really brief thumbnail, I just wanted to ask how many people in the audience might be interested in this program. So let me ask this quick poll question for you. Keep this open for about 30 seconds. And I'm going to, in the meantime, get the information. Oops, sorry about sharing that. Okay, and we'll close the poll. Okay. So about 3/4 of the folks in the audience are interested in this program. If you look in the chat box, you'll see a link, the same link as that QR code. And you'll also see the email address, askus@simplilearn.net, where you can contact one of our learning consultants to ask additional questions, see if this is something you'd like to enroll in. So with that, just want to say thank you to everybody here for attending. We really appreciate that. We do have an upcoming webinar for people who are looking for new jobs in software development. So again, I will put this information in the chat, but you can scan that QR code. It'll take you to the registration page for this webinar, where Pooja Subnani of GitHub will talk about what it's like to be on both sides of the interviewing process. She recently went through the process to get her new position at GitHub, and she also interviews software developers to join her team so she can give you advice on what to expect when you're interviewing and look at it from both perspectives. With that, I want to invite everyone to join us on our social media channels at Simplilearn on Facebook and Twitter, Simplilearn on LinkedIn. And with that, I'd like to conclude the webinar. So we hope that we can welcome you into our Simplilearn learning community, and we hope to see you at future webinars. Thank you so much.